Hello, my name is Oskar Dudycz, and today I'll be talking with you and trying to show you that CQRS might be simpler than you think, especially with new goodies from .NET 5 and C# 9. Who am I? I'm a developer, active developer for almost 14 years. I've been technical leader and architect, and right now I'm working in Event Store. Event Store is a database created especially for event sourcing, and I'm also a co-maintainer of also event sourcing framework, Martin. Martin allows to use Postgres as document database and event sourcing. However, I talked a lot about event sourcing, but today I won't be talking about event sourcing at all. So I will be trying to persuade you that maybe you could reevaluate whether clean architecture and in general layered architectures are not so maybe great as always. And that maybe a good alternative to consider is using slicing architecture, so CQRS. And that's almost all from our slides. We'll dive deeply into the code. So as you can see, this is a fancy file. We'll be working nicely on it. So let's start the talk about explaining what this enigmatic acronym CQRS in fact means. So C stands for comment, Q stands for query, and RS stands for responsibility segregation. So let's maybe at first start with defining what's comment and what's query, and then we'll jump why do we need to segregate them. So let's define the simplest comment you could imagine. So register product. And query will be get product details. So as you can see, those are really simple types definitions. And the only thing that differs them is name right now. So in fact, comment and query are both messages, they both are DTOs, and they both are used to initiate some behavior on our application. So comment is meant, the intent of comment is to mutate the state. In general, by the general rule, we should not be returning the data from comment. Of course, pragmatically, we can. However, as a general rule, main intention of comment is to mutate the state. Query, on the other hand, should not mutate the state, and that's the hard rule. And query should return the data. And why do we need to segregate those types of operations? Because that gives a lot of benefits. The easiest you can imagine is that by knowing whether the comment or query will be mutating or state or returning the data, you can optimize your application behavior. The other part is what I'm calling cognitive load. So how hard is to understand what's needed to create a new feature and how to understand the feature works. As we are slicing our application vertically by the business operations, then we can focus on working on the specific business feature rather than trying to put our pieces into the different layers in a horizontal layer. So how do we segregate the responsibility of our contracts? So the easiest way is to create interfaces for the handlers of our actions. So for commands, we will have an interface that will take the command and won't return any data. The value task name might be misleading. It means that this operation might be asynchronous, so it doesn't return any data. It's like a void within an asynchronous word. For the query, we are taking the query object and returning some specific result. For get product by details, this might be a single record. For list, it might be more. For some of them, this syntax, so record that I wrote, might be something new. So what's that weird syntax mean? In general, it means the same as we wrote the dumbest class without any methods and any properties. Record allows us to simplify the type definition syntax and make our code more concise. It has also other benefits, but also some cons, as we will see later on. So let's define like a real definition of our comment. So our comment, and in general, the domain that we will be discussing today, is the most cruddish example. So because I would like to show you that CQRS is simple and it doesn't require all those bullshit that sometimes you can see in the internet, right? And the product ID, the product number, name, description, that's nothing fancy. So how to create record? As I said, this is record is just another form of defining our classes. It's still reference types, so we can create a new comment, and we can put there some basic data. So as you can see, nothing fancy. We are just defining the data. We are giving ID, number, and description. And what's significant for records is when we try to update the data there, then like, for example, let's put their new ID, then compiler won't let us because it will say that this is init only property and you cannot initialize that once it was initiated. And the other thing that might be suspicious for you is this question mark. So this question mark is defined by the new goodies of the C# 8, not 9. And if we go to our definition of our project, then we can mark that our project will use nullable reference types. And nullable reference types means that we can also apply the nullability not only to the primitives like int, could, struct, etc., but we can also define that for reference types like strings, but also for the classes. So it's a really nice way, because if we like marked a name that it always has to be provided, or SKU, so the product number, then if we put null here, then a compiler will also block us and not allow us to use this value. However, this is not so perfect as it may seem, because if we add exclamation mark, and if you are coding in TypeScript, then you might be familiar with the exclamation mark usage, then that means that we are forcing .NET to take the null, and compiler not shout on us that we are putting a null, even though we define that we don't have to. So this is kind of not great from the nullability, because it appears that nullable reference types are just a syntactic sugar on top of the regular classes. So it's only compile time. It's not something that is built into the runtime. So it's not like you cannot provide null value. Like if you force compiler with the exclamation mark, or if you are running the deserialization, which might be even worse, then it still will allow you to put the null values. So I can imagine really nasty production bugs based on that. So let's see how records are defined, because it appears that records are also syntactic sugar on top of regular classes. So if we, so what this definition means precisely, it's more or less the same as we would provide a class and provide it like that. So, so by we are setting that let me just bring it again. So the fields that we defined here are just the properties that have a public getter and and new syntax. So init means that it allows you to set value only at the first time. So once you provided a value here, then you cannot assign it again. And this is like a definition of the class. So it is more or less the same, but not only, because if we still use record, because we can, then we will have the equality comparison. So we don't need to overload equality methods, which is tedious. And we don't need to also overwrite to string. We get it out of the box. So that's kind of cool. And the thing that I would like to also show you is that I like the type-driven development. So that's why I'm showing you this nullability, this immutability. So once I created object, then I would like to have a compiler check check my code for the easiest bugs. And also, even on the runtime, when I'm creating the object, then I would like to be able to, when I'm using created object, then it follows the set rules. With the primitive types, it's not easy because GUID might be, even though it's not nullable or string is not nullable, then they still might contain the empty values. So normally I'm using a static method, which is in functional word called smart constructor, which validates me all the input that I have, and it checks for the basic rules. We shouldn't check here like the business rules, rather the semantic rules. So like whether this is not empty, whether SKU is following some regex, etc. And so if I have this create method, and if I'm running this method instead, then if I write it here, good empty, or if I get null from then this method won't allow me to create invalid object. We will see later how this can be useful. But still, if I have this method, then I still have private public constructor, and I still can create invalid object. So that's why I'm normally setting that as a private. And then I can't create the object like that. Compiler won't allow me, but records have also other feature, which is kind of cool, but not always. If I want to have assurance about my types, then we could create something like that, wrong, and we can set it to register product with product ID, which is bad. And because compiler won't check me whether this is in fact private or not. So if I want to have a 100% sure that this object is immutable, won't be created with invalid values, then I need to remove the init and just let to be defined in the constructor. So this constructor won't have any rules, because if this can be used for the deserialization. So we can put JSON constructor here. And because if we are deserializing, then we kind of need to accept what values we got. And this will be used to create my objects. So if you don't want to do it, if you think that this is tedious, then of course you can just use raw records. But I don't think like this is a lot of additional work. Plus you can use some code generators for that. Okay, enough about the type-driven development, let's try to define how our query object will look like. So query object will follow the same conventions. So we will use the factory methods, private constructor, and get only property. Nothing fancy here. And let's define our data model. And as I mentioned, we will use the most crowdish example just to show you that even in such crowdish environment, you can benefit from CQRS. So this is product. It has currently exactly the same fields as our command and query. The good part about events, because we will be using ORM to make it more crowdish, then the good thing about Entity Framework Core 5 is that it allows to use the public and private non-default constructors. So you can follow the same rules I described. So you can be sure where the values are changed. And let's define also the database context, because we will be creating a real app, well, almost real app, at least a basic framework app. And what you can see here is, if we just extend it a bit, is the program file. Because in .NET 5, you can define whole program code within the single file, which might look weird, because if we are creating a bigger application, then normally the startup code or the program code we are changing only once. But this is a great feature for stuff like serverless to help reduce the cold start and further .NET runtime startup performance improvement. That's kind of important in many environments. So, but let's define some basic API. This is also new. So we have right now unified host environment for creating application, but we still can base on the web host. However, we need to use the extension method, and the web builder allows us to also define IOC. We can configure our application. We can still use startup, but as we started to use only single file for this definition, then let's continue. And the next part that I will be showing you are endpoints. So something that really enables, in my opinion, the CQRS for .NET. And to have that, we don't need to register whole MVC. We can cut off and leave only what's needed. So we just need to register routing. We will, of course, register our newly created DB context. And for endpoints, we can define them like that. So instead of defining our classes for and controllers, we can use methods like map_post or map_get. And those methods allows us to define a body and handling, which is more raw, but on the other hand, more flexible in a way that we can cut and leave only what's needed for us. So let's see how we could define those endpoints. So the new endpoints are not extremely new. They were introduced in .NET 3.0 or 3.1. However, they were really, really raw. Right now, they are much easier to use, because previously you needed to create your own deserialization of body, etc. Now you have a built-in method that allows you to read from request, read from JSON. What's more, we still can use the IOC and dependency injection. So we can use requested service, get service, and create and get injected DB context. Then we can, based on our command that we just deserialized, we could create our product, store it into the DB context using add async, save changes async. And as we are creating new object, then it would be great if we could return 201, so created HTTP status with the proper header and writing the product ID to our response. So we, as you see, this API is kind of raw, but we'll see how to make it clearer and easier to use. But it's still a kind of, by reading, you see what's happening. So we are deserializing command, we are running our business logic, if we can call this code a business logic, and then we are preparing the response. If we are using get, then that will be similar. So we will get the product ID from URL. So in endpoints, we can use exactly the same features around routing, middlewares, etc., as with the regular controllers. So you can picture those separate endpoints as controller methods. Still, they might look similar to even what you see in your project. So again, we can get the product ID, we can create a DB context, then we can run query, and if a product wasn't found, then we will return not found. And if the product was found, then we are just serializing and returning the value. So as you can see, we just created a really basic .NET application. It's not so huge. It has like 167 lines when 15 lines is the using block. But if I just call it a day, then you would say that this is yet another presentation with the basic example that is useless in the bigger application. So let's try to make it closer to the real product that needs to be extensible and that needs to be somehow grouped. I will show you how I typically structure my code base and how I run, how I set up the code. You can play with the endpoints, play with records, and define it on your own. You can write your own extension method, but this will be how I'm suggesting that. So treat it as a recommendation, not like all of that is must. So I'm usually splitting at first my main modules or services modules for a separate projects, and I'm creating there. Let me just. I'm creating there a folder per module. So, for example, I will create product. If I would like to have another submodule like inventory, then I will create a separate product and with a separate submodule and separate subfolder. And within this folder, I'm splitting, as I said, my code base in slices. So those slices can be like registering product. This can be get product details. We can extend it if we had like update product description. So another command. If we have another query, then we could create so on and so forth. Within within this slice, so as you can see, this is like splitted based on the business operation. Then we could create a file that will contain our root, so our endpoint. In this root, we can define an extension method that will just take this needed. That will just take endpoint root builder, and we will do a setup. If we go back to our definition, then this is exactly the same class. So we will use what we have here. And then we could just take it what we have here. So we can take map post and put it here. And we can return endpoints to have it more fluent way. And as you can see, we are missing some pieces. So let's define register product. And as I said, I like to keep the things together. So we can take our defined comment and put it here. So we will have together an endpoint, and we will have together a contract definition. And we need to also take our data model. So if we are following the domain-driven design approach, then this will be an aggregate that will contain methods. But this can be also a simple anemic model that we can just take it from here. So just definition of our product, because all those methods are around products. So that's why I'm grouping them together within the single module. And we are still missing the storage. So for the pragmatic reasons, like I will put it on top. So all the submodules will use the same DB context. But if you prefer, you can keep it also inside the single module. So we can take that part, cut it, and move it here. Let's just do it. Then again, let's see what we are missing. So let's now check what's wrong with our code. Let's add it here. Okay. So if we see here, then we are deserializing the register product. But as I said, we would like to keep the comment strongly typed, and this this method won't be used at all within deserialization process. Also, because nullable types, records, etc., are just syntactic sugar, then I don't trust those code that is called from the API. So normally, I'm just using the request class, which has everything nullable and have everything that I'm unsure, like a nullable, primitive types, etc. And then having that, I'm not using the real command. I'm treating the command as a part of my domain. So I would like to be sure that this is fine. And I'm using this request method here. And this is something that I don't trust at all. So I can create, that's also the reason why I created a comment to have the validation. So I'm just creating a comment. And as you see, product ID, that's something that is not provided from the API because we are unsure. We don't need the ID. So that's why I'm just creating it here and creating a comment. And if we, so right now, what to do with our comment? So with our comment, I'm in general splitting my code. I'm trying to keep my things simple. So I have this endpoint, which the main idea behind that is to prepare my business domain objects from the request, and then map the result of my operation to the external world, so serialize it and so on. But I would like to have my business logic not tangled to some HTTP context, etc. So as I said, we also defined the comment handlers and query handlers. So let's use them here and keep the business logic separated. So as you see, I just created a simple class that have implemented iComment handler. It takes registered product comment. And what we can put here is at first move our command also to the same file. So we will be keeping the code that changes together at the same place. So we will have our root definition together with our HTTP endpoint contract, and we will have a handler together with the comment. Because normally, if we are changing comment, then we also need to change the command handling. So what we're gonna need, because we would like to keep this logic separated from like entity framework classes, from HTTP context, etc. That's at least how I'm usually working on it. So we will need to have two methods to run our logic. First one will be the method that will add new product. And the other one, we would like to at least mimic some simple business logic. So check whether product with the SKU, so the product number does not exist. Okay, so let's try to move it. So again, as you can see, we will, based on the command, we will create new product. And this will be a bit different to what we saw here, because when previously we were deserializing, then we were even unsure whether this command is null or not. So we needed to force the compiler that we know what we are doing. So as we don't need it anymore, then see, we are getting trust with our code base. So if we didn't validate the business logic, the semantics of our command here, then we would need to like make our logic more messy, because we would need to have all those ifs, like if comment not equal null, then comment ID is not equal good empty, and so on and so forth. So we would need to write a lot of ifs here, and we would need to write also a lot of unit tests about that. If we are making sure that our value objects are properly created and semantically correct, then within our handlers, we don't need to think about that. We can trust them. So what we need to do is to just run the real business logic, and we can focus on this exact business logic. So we can run the method and verify whether the product with SKU exists. If not, then if it exists, then we cannot create additional product, and we can just run. Then if everything is fine, then we can run add product method and call it a day. So let's get back to our root, because it still looks quite raw. So if this part we already moved to our domain handler, this looks valid, and that's also a cool part of the records. So you can deconstruct them in a similar way as it is in JavaScript or TypeScript. So you can just take the values. If you don't need to use it, then you can do it like that. And it makes code cleaner. And as I mentioned, we will be using some improvements and some helper methods to make everything simpler. So instead of creating DB context here, then we can try to get the command handler for our registered product, because that's what we will be doing. Okay. And yep. Okay. We are missing one bracket. And if we have this handler, then we can call it like handler, handle, and place command here. But still, it's quite tedious, right? So I created few simple methods that will help on that. So if we call it get command handler for our command, okay, sorry, let's check it. Let's use a proper using. Sorry. Get command handler, then it will return as automatically the command handler, but we can go even further and we can define like a method that is send command that we will just put a comment here and this will be done internally. So what you might glimpse a bit, then send command is calling the get command handler method, and then it's just calling command. And that is kind of great because if we have that definition, then we don't need patterns like mediate classes like mediator. We don't need to. We can still get benefit of the built-in middlewares, and we can still have inject here the wrappers around our command handlers so we can build our own pipelines. So let's wrap it if we use command handler, and we can also take this whole stuff, and as Camille said, we could extract method and write a simple wrapper and have short, concise code, right? So if we define, so this, in my opinion, looks really short and neat. So the same will be exactly for our query handling. So we can define a route. We can take exactly the same pattern. So build our query, send query from context if it wasn't found and not found. If everything is fine, then okay. And again, simple method to wrap the, here is for created, here is for okay. And we can add simple query handler. And this will look kind of also similar. So we have, again, our contract definition, so our query definition and our details. And we have a query handler that is just using iQueryable. We could inject here connection if we want, whatever, however we would like to keep it separated. And again, even on the such registration, we can get a benefit of setting, of using CQRS, because, for example, we can inject here queryable as no tracking, and we will be having disabled change tracking, so the queries will run faster because we want entity framework don't need to track our object and make sure that we didn't check anything here. But the performance optimization is just an additional result of our restructuring. So for me, the biggest benefit, to sum up, is that we can keep a bigger cohesion. So we pieces that are changing together, I kept at the one place, and reduce the coupling, especially between layers. So for example, if we had a method like getList or filter product, then we could just even take that part and move it to separate module, to separate even microservice, and just even replace the Postgres or relational database with the Elasticsearch. So using CQRS can help to structure basic application, but in my opinion, it makes also our product easier to evolve because we have this vertical split. So if we are changing anything in register product, we can go even to some row customization, like changing headers, etc., without impacting all the other routings. If we are just using such a simple mappers, like for my HTTP handling mapping, it's only 100 lines of code, and it supports like getting things from body, from query, etc. So it's not so hard. And in .NET 6, it will be even simpler because there will be a model binding. So, and what endpoints are missing? Endpoints are missing right now. The only thing that I found is missing Swagger. However, I asked David Fowler on Twitter, and he said that they are working on that to have it enabled in .NET 6. But I think that it's possible to provide some custom Swagger discovery. If we would like to make it even more extreme, then we could even cut all that registration, make it by convention. But on the other hand, that would be the opposite result of what we would like to achieve, because what we want to achieve is the composability. So we are using simple code with simple methods that are separated from each other. So if we are changing the behavior of how to handle the specific commands, then we are minimizing the risk on impacting all the other business logic. And to sum up, that's all. I would like to thank you for being with me. The source codes are already available. If you go to my eventsourcing.net core repository, then there is a samples folder where you can find a warehouse. It's even extended version. There is also pull request with the extreme convention registration by convention. And I would be extremely grateful for any feedback, especially the constructive criticism, because that will help me to improve and will help me to improve my presentation and way of thinking. And I will be on Discord. I will be here on the chat. So if you have any question, feel free to write on my email, write me on Discord, ask any questions on Twitter. And thank you a lot. Wish you a great rest of the conference and seeing you another time.